Okay, the first two problems on my list here are related. We're to find the amplitude, period, and phase shift of this function, and then to graph it. So let's do what we can with a calculator first. This is oftentimes a great way to get started. And what we want to do here is make sure we're in the right mode before we start. So this is in radian mode. And then I'll type in the function. Now I've actually I've typed it in two different forms. So I will come back to that in just a minute. But this one right here, 3 times the sine of 2/3 x minus pi over 3 is right here. 2/3 x minus pi over 3 is what we're looking for next. There it is. And what I'm going to do is, rather to save myself the trouble of typing this in again, I am going to highlight that and press enter. And notice it turns off that equal sign. So this one won't graph in just that top one there. And if I set my zoom to the standard trig window, I should get a look at this. And there's a lot here that you could pick out pretty easily. We can see that, first of all, this is stretched out in the horizontal direction. So the period is going to be more than 2 pi. Now, if I look at the standard trig window, put these tick marks at every pi over 2 units. And if you were to click on the window, you can actually see that that's this number right here is pi over 2. If you want to make sure that's how that was set, by the way, you just type it in, pi divided by 2, press enter, and there it is. But that's the same graph I had before. Let's see, I've got half, 1 1/2, 2 1/2. Looks like I have a period of 3 pi now. And this intercept here appears to be shifted to the left. Or, well, maybe not, because the standard sign goes up first, right? So maybe that's shifted to the right. It looks like by pi over 2. And it's kind of hard to read a lot of detail off of here, but we get a general idea. It's taller than the regular sine function. Looks like a height of about 3 and a depth of about -3. Let's write down what we can now from doing some analysis. So this is our function here. This coefficient right here always gives us the amplitude. And what you do is you take the absolute value of that coefficient. Absolute value of 3 is 3. So that's the amplitude. That's how tall the peaks and how low the valleys should go on the sine function. Now, the next couple of things, we want to know the phase shift and the period. We're actually going to have to do a little bit of calculation for that. I've got a coefficient on the x here that's not just 1, so that needs to be factored off to here. So I am going to look at this function here and say what I really would like to do is to get a 2/3 off of this, but then also off of this. Now the way to do that, let's just rewrite it a little. I've got the 3 in the denominator already, so that's good, but I need a 2 in the numerator I can factor off. So the trick is to multiply top and bottom by 2. So I have 2 pi in the top, and I'll have another 2 down here. I could write, of course we all know 2 times 3 is 6, right? But I'm going to factor that 3 out, so it's really a little nicer to leave it this way. So my function, y, is equal to 3 sine, take the 2/3 out, and then 2/3 times x is 2/3 x, so just x left here. I'm taking the 2/3 out, and I'm left with pi over 2. Now that pi over 2 is my phase shift. So you need a minus to read it. So if this were a plus, and we'd say the phase shift is a minus pi over 2. So phase shift in this case is pi over 2. And by the way, that corresponds with a graph, right? This intercept, the one where this graph starts going up, is pi over 2 units to the right of where we'd expect it. And by the way, you can see that 1, 2, 3 amplitude there as well. The last thing that we want to get is the period. And what you do is you take the period of the standard sine function, which is 2 pi. That's just the distance to go through one cycle, so 2 pi, from 0 to 2 pi. And you divide it by this coefficient right here, 2/3. You could just divide it by the coefficient on x here. That would be fine too. So dividing by 2/3 is the same as multiplying by 3/2. So the 2's cancel out, and we get 3 pi for a period. So period's 3 pi, phase shift is pi over 2, amplitude is 3. So that answers the first question. The second question is to graph this function. Well, we have an approximate graph of it right here. By the way, if we wanted to see that in a little different window, a couple of options. We could go to the window here and just change it. Or another thing you can do is if you want to get it to scroll, is to press on the trace key and just keep tracing the function until you see more of it, and it will scroll the window so that you can see that. So I'd like to see that next. I'd like to see 3 intercepts is what I'd like. And again now, looks like we got the first intercept at pi over 2. Then now every one of these tick marks is a half a pi. So 1 pi, 2 pi, 3 pi. That makes sense. We're supposed to have a period of 3 pi, and we do. It takes another 3 pi units, so we're at 3.5 pi or 7 pi over 2 to get back to this intercept. Now that actually allows me to get these 3 intercept points right here, and I would like to get the coordinates of the peak and the valley. Now the peak we know is that the y-coordinate is 3 because that's the amplitude, and therefore the y-coordinate here is going to be -3, but we don't know the x-coordinates just yet. Couple of options there. Option number 1. What I've done here is I'm going into the details of question number 2. What are the coordinates of the maximum? Well, one possibility would be this. I know that I have intercepts at, well, where did I get them? Pi over 2, pi, 3 pi over 2, 2 pi, and then this one, if you recall, that was 3.5 pi. So that's pi, 2 pi, 3 pi, and 1/2 pi. So 3.5 pi, which is 7 pi over 2. Now, you just notice that this is a distance. You add 1.5 pi to get from here to here, and you add 1.5 pi to get from here to here. 1.5 pi is 3/2 pi. So that's the distance between intercepts. So half that distance, 3 pi over 2, is the distance from an intercept to the max. So from this intercept here to this max here on our modified function is going to be, that distance is going to be 3 pi over 4. Well, we know that the intercept, the x-coordinate of the intercept was pi over 2. You could get that off the graph, or we could compute it, and then we will add 3 pi over 4. So I have This is 2 pi over 4 plus 3 pi over 4 makes 5 pi over 4 is the x-coordinate of the max, and the xy pair then would be 5 pi over 4, comma, and the amplitude is 3, so the y-coordinate is 3. Then this intercept is at 2 pi, I think. 1, 2, yep, 2 pi. And then we'd add the same thing. 2 pi plus 3 pi over 4 is going to give me the x-coordinate of the minimum. So I've changed headings here. 2 pi plus 3 pi over 4. Well, let's see. This is 8 pi over 4 plus 3 pi over 4 makes 11 pi over 4. And there's the x-coordinate of the minimum. And by the way, if I add another 3 pi over 4 here, I would be at, let's see, 11 pi over 4 plus 3 pi over 4 would be 14 pi over 4, which is 7 pi over 2, which is 3.5 units of pi. And 3.5 pi is where we are expecting to find the next intercept. And sure enough, this is 1, 2, 3.5 pi is where that intercept is. So that's one way of getting it from geometry. The other option you do have always is to simply solve equations. I could take this. This is called the argument of the sine function. I could work in this form, or I can work in this form. It doesn't matter. They're equivalent. I'm going to choose this one here. I think it's turns out to be a little bit more convenient. So 2/3 times x minus pi over 2, the argument of the sine function, right there, copying it down, and then I just set it to the inputs that will cause the sine to be equal to 0, its maximum, 0, its minimum, and then 0 again. Well, those the x-coordinates of those points are 0, pi over 2, pi, etc., onto 2 pi. So you solve it for that, and then you would solve it for that, and then that, and then that, and finally 2 pi. So the 1, 2, 3, 4, 5 points of interest. This, what I mean by this is it's 5 equations. You solve this one, it's equal to 0. It should give you that. It should give you the x-coordinate of what happens to that first intercept. Let's try one of those. So I'm solving this equation right here. 2/3 times x minus pi over 2. Multiply both sides by 3/2, and it cancels out the 2/3 here. And of course, 3/2 times 0 is still 0. So x equals pi over 2, and therefore the x-coordinate of that first intercept, and an x-intercept always has height 0. So pi over 2, 0 is where I ought to be seeing that first intercept. And sure enough, it's right there, pi over 2, 0. What's this guy right here? Well, that is where this argument is equal to pi over 2. So let's solve that one. 2/3 times x minus pi over 2 is equal to pi over 2. So you, let's see, you would multiply each side by 3 and divide by 2. Multiplying by 3, dividing by 2, and then I add pi over 2 to both sides. 3 pi over 4 plus pi over 2. So 3 pi over 4 plus pi over 2 gives 5 pi over 4, and that is where we are expecting to find the maximum. So we have, of course, this basic shape that we're working with, and we have now computed the location of these points. So we know that that started at pi over 2, so let's kind of get our units marked out. We ended up at 3.5 pi, so that was a 0. Started out at pi over 2. That was a 0. Then halfway between there is where our other intercept is. Turns out 3.5 plus a half makes 4. Divide by 2 is 2. So the average, or the middle, is right at 2 pi. And then at pi plus a quarter pi, 5 pi over 4 is where this point is. Trying to make a curve here. And then this one right midway is where that minimum is. And this could be computed as we did before from geometry. So this distance is 3/2 pi, and therefore half of that distance is 3/4 pi, so 2 3/4 pi (11/4) for 2 3/4, and therefore 11 pi over 4 comma minus 3 are the coordinates of that point. Now, keep in mind, you can always kind of test to see if things are working. If I have 11 divided by 4 times pi, I'm expecting about 8.64, 8.639. So let's go back to our graph, and we're computing the coordinates of that minimum. If I trace it, .639 is not a bad guess, and minus 3, so yeah, seems to work. By the way, I've had a couple of questions about, can you somehow get these numbers out of the calculator and turn them into exact values? And the answer in general is no. But what you can do is compute the exact values and then check and see if they seem like a reasonable match to what you're seeing on the calculator. Okay, that's the solution to the first two problems.